So it will bring up another line like this. Let me assign the origin, which is 0. Even in graphical notation, if you try to draw a graph, a two-dimensional graph that has a width and a height, or the x-axis and the y-axis, you will obviously find that the origin will always start from 0 and 0 for both the x-axis and for both and also for the y-axis. Even if you include a third dimension, which is the z-index, you will always start the z-index with an origin which will start from the value of 0. Now, um, before we proceed with the coordinate system, let me show you one thing. So this is one point on the number line. So this can be referred to as point 1. But this point does not have a certain value. We haven't assigned any sort of value to this point. So this point can hold any sort of value. It can hold 1, it can hold 10, it can hold 100, it can hold 100 billion. So this point doesn't represent any sort of value. So in terms of linear coordinate system, when we try to assign a value to a certain point on a number line, we refer to that value as the coordinate. So in this case, if this point consists of the origin, or if this point is the origin of this number line, so this point will obviously contain the value of 0. So this point now has the coordinate of 0, or this point P1 now has the coordinate value of 0. So in terms of this linear terminologies, you can even say the point is 0 rather than saying the coordinate of this point P1 is 0. So that's a lengthy thing, so we don't need to bother about such lengthy stuff. The next thing that we must look into is the absolute value system. So this was the linear coordinate system. Let me scroll down. So the next thing is the absolute value system. To discuss about this absolute value system, we must consider a variable called x. So this variable, so there is a certain misunderstanding when we try to talk about constant numbers and variables. So constant numbers are just coordinates on the number line, and variables can be any point or any coordinate or any constant at a given time. So so the value for the x actually varies. So when we talk about a constant, like 1 is a constant, 2 is a constant on the number line, and even this 0, which is the origin, is also a constant value. But x can refer to 0 at one time, x can even refer to 1 at another time, then x can also refer to 1 and 2 or 12 or 13 or 100 at another given time. So the variable x actually means that it uh, it actually holds a constant number inside it at a given point of time. So this is one of the essential part when we talk about calculus, and this has led to the development of computer programming languages through algorithms. So inside programming languages, we obviously have to use variables. If you're not familiar with any programming language, then you must understand that every programming language must have the construct of variable. So a variable is a certain construct or a certain arbitrary value that can hold a constant value like this, a constant coordinate at any given time. And after the user or after you actually think that you don't need that constant right now, like currently x can contain 0. So uh, we think that we don't need that 0 right now, so we can actually uh, tell we can actually assign 1 to this variable. So this 0 is actually a constant, this 1 is a constant, but this x is the same x. This 0 is not the same as 1. You can't say 0 is equals to 1. So this x is the same because at one time, like in minute 1, we can say that the variable x contains 0. At minute 2, we can say sorry, at minute 2 we can say the variable x contains 1. So the previous value, which was 0, has been erased off, and instead of that 0, this variable x contains the value of 1. So this is very important concept. This is a very fundamental concept in algorithms. When you design algorithms and when you try to implement that algorithm inside inside using any programming language. So this is very important because we need to determine how a program will run. Our efficiency depends on the amount of time taken by the program to run. Nonetheless, as we are talking about calculus, let's move on to what's called the absolute value system. So let's consider that we have a number inside this variable x. So this variable x now contains a certain sort of number, which can be 0, which can be 1.2, which can be 100, which can be 100.01, any number. So this absolute value is denoted by modulus, and placing those two bars enclosed, but the x is actually enclosed by two bars. So uh, this is actually known as the value of the absolute value of x. So the absolute value of x will always be a non-negative number. So the condition for when we apply these two bars, or when we enclose this x with these two bars, we actually mean that